Greetings. Welcome to this video on creating a reciprocating rod attached to a wheel. The first thing to do is go into Preferences, into Home at 2D, and check to make sure that the experimental feature to automatically modify expression on moving referenced objects is ticked. What that will do is keep the expressions that are created in sync with the column numbers if they should change as you move columns within the timeline or the X sheet. So first, create a new vector layer, call it main wheel, and on that layer, at the center, notice the red X, that's indicating the camera center. If you're not seeing the camera center, go to View and tick the box that says Camera Box. And that will show this reference mark. Use the geometry tool, and set the shape to circle. And as you create the circle, go ahead and press the Alt key so that the circle is created radiating outward from the center of where you click rather than following your cursor. This way it's easier to keep it centered near that red X. It still can be tricky to get it just right. So once you've created the circle, if you need to realign it, use the selection tool and draw a selection box. And then you can really zoom in, not so far that you can't have access to the dashed line because you need to click that dashed line in order to move. You can see I'm off just slightly to the left. First, I'll click the dashed line, then I'll hold the Shift key, then I'll move it slightly. There'll be snapping that will occur if you're not holding the Shift key down. Then I'll release the Shift key. Now I'm able to move freely without the snapping happening. So then I can move, get it as close as I possibly can to the center of that red X. So again, that was go into selection mode, draw a selection box, and then with the mouse, left click on the dashed line to activate the move mode. Notice it kind of jumps around. It wants to snap to the last position that you were in, which in my case right now is good because it's going to go to the center where I had put it. But in your case, you'll have to hold the Shift key down while still holding the left mouse button. Hold the Shift key, just move a little bit, release the Shift key. Now you're free from the snapping. It temporarily turns off the snapping. And then just get it right back into that spot where you want it so that the center of your selection is right as close as you can to the middle of that red X. And that's what you want. You can also embellish the wheel, make it look a little more wheel-like. You can use a simple circle, filled circle if you'd like. But I'd try to make mine look a little more wheel-like so that I could notice its rotation. And another tip that I have is create a new color and use the brush tool to just put a nice little circle at the top of the wheel so that that's your reference point as to what your starting point was. So you can watch the revolution of the wheel, and it helps guide later steps where a pivot point is going to be located somewhere below that top center of the wheel. Next, create a rectangle and call that side rod. Now these terms that I'm using are in reference to a steam engine. So this example is based on a steam engine, how the rods and the wheels are connected to drive the train forward. So create that rectangle, just a long, thin rectangle positioned horizontally. Now there's some leeway that will be possible. Your circle won't necessarily be the same size as my circle for the wheel. So measurements that you see on my screen won't match the measurements that you have on your screen. But this can all work. It's just understanding where those measurements are different, how that affects the formulas and so forth. So don't worry too much about that precision. Just get the main concepts down If the end result doesn't look perfect, do it again, do it a couple of times. Just reinforce the knowledge of how to link things together using expressions and a little bit of parenting of columns within Tahoma 2D. Next step to do is to move that center point of the column so that it is near one end of the rod, and that's going to be its pivot point where it will attach to the wheel. So go to the Animate Tool, choose Center, and position that center near the right-hand side of the side rod. Once that is done, let's parent that in the stage schematic to the main wheel. So just drag and drop the dot from the blue dot from side rod to the main wheel so that it is parented to the main wheel. Once you've done that, move it up slightly. In my case, I moved it up using the position setting now on the Animate Tool. I moved it up 30 pixels. Try to use a good round number like that because it makes it easier in formulas later on. You don't want to be typing decimal numbers if you can avoid it. So a nice number, depending on the size of your wheel. You don't want it to go all the way to the end of the wheel necessarily. I mean, you could, but it's typically attached halfway, but generally somewhere between the axle, the center of the wheel, and the outer rim of the wheel. That's where it would be attached. Next, we're going to rotate the wheel, and the way to do that is to use, what I typically do is I go into the timing room and I will set some keyframes, some keys on the rotation value for the wheel. So if you go to frame 1 and put in a value of 0 for the rotation, and then you can see I've set up my animation to run for 96 frames, actually 97, just because I wanted a frame afterwards, a quiet frame where it wasn't doing anything, to check my work. And in order to loop, we actually don't play frame 96 because that's going to equal the same value of rotation as frame 1. In other words, that's going to be 360, so the wheel will be back in the position it was when it started at frame 1. So you want to do the same. Go to the 96th frame and put in a value of, well, in this case I have 720 because I was testing having it rotate twice. I'm going to put it to 360. So we'll rotate once within 96 frames. Now when I hit play, it's rotating nicely in my case. In your case, the rod is probably sticking out sideways like a spoke and going around with the wheel. That's going to lead us to the next step. The way we stop the rod from spinning around that way is we go to timing, and this time we're looking for the side rod rotation value. Oh, and if it gets cluttered on your screen, as you see here, just right-click and choose Show Animated Only. And that would hide all the columns that are not being animated. Well, it's supposed to do that. Good enough. In the rotation column for a side rod, you want to set an expression, and you want that to be minus, and you want to use the column number of the wheel. So main wheel for me is column 1. It most likely is column 1 for you as well, but you can check in the hierarchy table within the timing room. So I set col 1 I set the value to minus column 1 rotation. The reason for that is, since we've done parenting, as this column rotates with the wheel on it, it's going to take along the column with the side rod on it. It's going to rotate as well. So through this expression, I'm saying I want to negate, I want to reverse out the change of rotation that the parent is doing. So as the main wheel rotates, the side rod is, in a sense, rotating in the opposite direction so that it stays in place. And that's how you'll get this. So now you should have something like that on your drawing. Now you're going to add a second wheel and call it wheel 2. An easy way to do this is to reuse the same level that was used for the main wheel. So highlight, select the main wheel, right-click, copy, and then do a right-click. Well, still with main wheel selected, do a right-click and say Paste Insert Above. Now you'll have that same level, that same drawing, exposed on a second column. Call it Wheel 2, and then use the Animate Tool to move it over to the left. So in the same way that you have the side rod near the top of the main wheel, you want that side rod to be near the top of Wheel 2, with Wheel 2 being further to the left. Now we want Wheel 2 to rotate in synchronization with the main wheel. So we go back to the timing room, and we look at Wheel 2's rotation, and set an expression. Set an expression on Wheel 2's rotation to be equal to main wheel's rotation. Column 1 is main wheel, so we just put a value of col1.rot for rotation. Click Apply. Now you should have something like this. Next, add a second rod. And this one's going to be a little longer than the side rod, and give it the name main rod. Add another layer, a level, I should say, and create a rectangle and call that crosshead. In the same way that the wheel was created near the center, near that red X, create crosshead the same way, and then use the Animate Tool to slide it over so that it stays in line with this horizontal level of the wheel. Essentially, just move it along the X-axis. Don't move it along the Y-axis. Leave Y at 0. Just move it along the X-axis so that it's somewhere out beyond the main rod. Ultimately, the main rod is going to connect to it. Your main rod is probably not angled like mine is on the screen right now. It's probably very parallel to the side rod. Next, we're going to connect the main rod to the same pivot point that the side rod is connected to on the wheel. We're going to do that using an expression on the main rod X and Y. We go to the timing room, look for main rod, X and Y, and we're going to use trigonometry formulas. And these formulas are used because what we're doing is we are getting a point on a rotating wheel. So a point on this circle, which is the main wheel. Put in a formula similar to what I show on screen here. Column 1 is the wheel, so whichever column is the wheel in your case, use that in your formula. And again, this is the X formula, is using sine function. That 30, if you remember back to the position of the side rod, it was 30 pixels above the center of the axle of the main wheel. So 30 is our radius. That's the radius of the circle that we're trying to map these points onto. So whatever your pivot point was for the side rod, use that same value here. That's your radius. And then the sine function. And column 1 is our wheel, so whatever column is your main wheel, you want that rotation angle to be in this part of the formula. Then click Apply. Do a similar thing for the main rod Y value. Set up an expression. This time we're using cosine. And, well, the last formula should have also had this addition to it as well. But we'll let it go for the moment. It seems to be working. Put in the wheel's angle here again, column 1 rotation, and 30 is our radius. And in this case, it's adding the wheel's north-south value. Now, on screen and in my example, I've kept the wheel centered at 0, 0. So technically this little part isn't going to make a difference. But if I were to move the wheel, then it would make a difference, because the actual value we're looking for is the X and Y coordinates on the screen, not just relative to the main rod connecting to the wheel. We want sort of the global value that applies no matter where we are on the screen. So I'm going to correct this formula. This formula is also going to have column 1's value. So what we're calculating here is an X value. There's two ways to refer to the X axis within Tahoma 2D. One is to say east-west. Another is to use the value of X. Let me just change that to X. Oops. That's something I noticed. You saw there the formula kind of jumped away on me. I have to hit Control-Z to get it back. What was happening was I was trying to edit this line and I hit the delete key, but instead it deleted the entire formula. You may run into a situation like that yourself. Just have to be patient, be careful, and if it ever disappears like that on you, just hit Control-Z to get it back. It was an accidental delete. It's a little finicky, but it will work. You just have to be patient. There's a lot of patience required working with expressions this way. So I click Apply. Now nothing moved over here because that value is actually 0. The wheel is sitting at X equals 0, Y equals 0. But if I were to move that wheel, I would want this value to follow along. Okay. Next, we're going to set the X value of the crosshead to equal the same X value that we just got for the main rod. One of the things you'll find in working with formulas this way, associating different elements on the screen, is you want to stay consistent. You want to try to use the same reference point each time so that things stay attached to one another, that it visually gives you the result you're looking for. Try not to keep recreating formulas. Just try to refer to the same value whenever possible. So on the crosshead X expression, what I'm referring to here, well, I just counteracted what I said. We're using the formula again, so you'll recognize this part of it is what we just calculated for the main rod X value. What I could be saying here instead, Oops, there again, I hit the delete key and the whole formula disappeared instead of just deleting what I wanted to. So I guess doing a selection like this and hitting delete gives you a bad result. Don't do it. Just click somewhere between characters and then you can use the delete key. Apparently, if you do a selection and then the delete key, it's just going to wipe out that whole formula. Okay. So I'm going to hold the, just tap the delete key and get it to a simpler formula. I'm going to refer to the X value of the main rod, which I already had that formula in, rather than repeat the formula. So the main rod is column 4. So I'll say column 4 dot X. Good. I didn't see anything move over here in the results, and I didn't expect anything to. What I've done here is, instead of repeating that complex formula, instead I said, you know what, the crosshead, this rectangle, is going to follow the same path in terms of X value that this point around the wheel is going to follow. That's generally true. You know, to be absolutely accurate, you would recognize that when you go up and down a little bit, you're actually shortening the distance X along the X-axis. But this is close enough, and I'll refer to this in the notes that I post in the description for this video. It's close enough that the audience won't notice a difference. You won't notice it at the scales we're working at within the animation. So it's good enough to say, I want to use the same X value for the crosshead moving back and forth that I'm using for the main rod moving along the X-axis. So rather than repeat the formula, I'm just going to point to where that value had already been calculated. So as a correction to the formula that I had entered earlier for crosshead X value, it's a plus sign that goes here. So the calculation of the X connection point going around main wheel needs to be added to the offset of the crosshead along the X axis. And that gives us the result that I'm looking for. The crosshead will now follow along with the rotation of main wheel, moving along the X-axis, looking connected to the main rod. I haven't been pointing this out so far in the video, but you want to do saves. Save early, save often, as much as you can. Every time you think of it, hit Control-S to do a save. Okay, now we want the crosshead to be constrained along the y-axis. I don't want the crosshead to move up and down on the y-axis. On the actual train, it's made so that it slides back and forth. It will not go up and down. So the way we fix it along that y-axis is put in an expression, and for the expression value, we're just going to give it a number, and we're going to say 0. I don't want it to move up and down. Or I want this to be actually the same value. I want it to be, in this case, along the same axis as the center of the wheel. So I'll say column 1, Y value. That means that the crosshead is going to stay in the same relationship to the wheel. If I were to ever move things around, it won't get left behind. Now for the final step, we're going to set the main rod to point to the center of the crosshead. So that means we're going to need the rotation value of the main rod, and we're going to set a formula there, and that's the most complex formula out of this whole exercise. So let me break it down a little bit. Again, what we're doing is we're tracking a point around a circle, and then we're going to, from that, derive an XY coordinate, and we're going to establish an angle between that XY coordinate and the XY coordinate, which represents where is the crosshead at this current point in time. So that formula is going to be, the example formula is going to be in the comments for this video. You're going to be able to copy and paste it and then modify it. And I've broken out a description here based on the values that you see within the formula. It helps a lot to take a formula like this, and rather than try to work in this tiny little window within Tahoma 2D, go ahead and put it into Notepad or some other text editor. And then you can break it apart. While it's not being actively used, you can add spaces, additional spaces in there. You can make it however you need it to be formatted so that you can see the pieces of what's going on. And use parentheses anytime you want a section of the formula to complete before the rest of the formula is calculated. You put parentheses around that section. It affects what's called the order of precedence. You want to make sure that, in this case, the value for y is being calculated before the crosshead value for y is subtracted. And so you see this formula is what you had seen before. Now, as I'm talking, and as we did with the crosshead, I believe I can actually refer to the result that's already been calculated for the main bar, the main rod. Let me try that. I'm going to change this. Instead of that complex formula, which we've already calculated, I'm going to refer to the column 4 Y value, main rod. And similarly for the X value. So I'll end up with a much simplified formula like that. Okay, let me test this. I'm going to put the original formula back over here as reference. Make sure that I don't lose it because I know it works. And then I'm going to take this modified version and paste it over there and see if things still work or if they go all crazy. Ah, good. No change over there, which means I'm getting the same result I was hoping for. Okay, hopefully that completes the setup for you as well, and you'll get results the same as what I'm showing here, or very similar. Set the, we call that the stop marker at frame 95. Hit the loop button, and you should see the wheels rotating, and you should see the sidebar and the main bar, main rod and side rod following along with the wheels, and the crosshead staying connected to the end of the main rod. I've turned down the opacity and added a red dot to the crosshead in my case, so that when I was testing, I was able to see what was going on with the main rod, seeing it through the transparent crosshead. You can do a similar thing if you'd like. Just turn down the opacity, something like I did here, 80%. Okay, that concludes the setup of what I wanted to cover. Now I've added some additional points in the description for this video, which you can read through. Don't really need to present them in lecture format, so they're there as reference. I just put down some of my notes, things that I was thinking about when I set this animation up. One of the key things is, what is the hierarchy? What is the order that things will be connected? And I chose to use the wheel, main wheel first, and work backward from there, connecting things to it. You could have tried a different approach. Could have taken the crosshead, started there, and then try to calculate all the formulas for the other parts in reference to that. And that's where experience and a little bit of trial and error is going to come into play as you work on your own animations going forward. You just decide what's primary, what is the primary thing that needs to sort of be the top of the hierarchy that all the other things will try to follow behind, and then use the different methods of linking the animation components, whether it be parenting using the stage schematic, or skeleton within the plastic tool, or expressions. However you do it, however you link things together, it would be following that understood hierarchy of what's the primary element here that I'm going to animate, that I want the other things to follow behind. I also put some tips in the description talking about fine-tuning. I had some good lessons learned in working out this exercise so that the end of these two rods would stay synchronized with the wheel, and they wouldn't like shift one above the other, and it wouldn't look like a loose connection. It took some understanding that I had to go through the process to learn, which I've tried to present in this video, of how to have the expressions refer to the same values, to not try to mix different ways of connecting, like do parenting in one case and then do expressions in another, when really they should both be doing either parenting or expressions, so that the way the X and Y values are calculated stays consistent. It's easy to get out of alignment by not following those guidelines. Okay, that wraps up this video. Thank you very much for watching.